Now let's pick up talking about something called enthalpy, and the symbol for enthalpy is H, whereas the symbol for internal energy was U. And we learned a couple things about internal energy previously by talking about U. Now enthalpy, its formal definition is U plus PV. So it is equal to the internal energy plus the pressure times the volume. And that's not going to be as useful to us as we would like. And if you want more details about this particular relationship, please talk to me in office hours or see chapter 6 in the online text for more details. But what we want to know is actually not technically H, but we're going to talk more about delta H, okay? And delta H is going to equal delta U. So the change in enthalpy is going to equal the change in internal energy plus P delta V plus delta P, let's do this, V delta P. And what we will do is we will restrict our case to, or our work for calculations in which pressure is constant which means delta P equals 0. And so the definition that we want to work with is actually for delta H, and it is going to equal delta U plus P delta V, where P delta V is the pressure volume work that we've talked about in the previous part of this lecture outline. Okay. And this is going to be at constant pressure. So delta H is constant pressure. And constant pressure is a good place to be. Everything we do is done, and so as far as generally in chemistry, is done at 1 atmosphere, very close, and that pressure is constant when we're in the lab, when we're doing experiments, when we're cooking at home. So now this, its formal name is the change in enthalpy. And its working definition, or its working name, is going to be the change in heat energy. And the change in heat energy is going to be significant because that heat energy, either given off or taken in, will be indicative of a change in potential energy of the system. So it's going to be indicative of a change in potential energy where potential energy is PE of the system. So we're going to be able to say things about the system based on whether it gives off or takes in energy, and we're going to be able to say things about the bonds. That's where we're working towards anyway. For most processes, delta H is very close to delta U, and so and truly, when there's no change in volume, or change in pressure, delta H equals delta U. And so we're going to focus on delta H. Delta H is the most useful part of this, what we're doing. And we're going to calculate, we're going to have the rest of this chapter is understanding 3 ways to determine delta H for a process, specifically for a reaction. Okay, so we're building up how to do it, and then we're going to do it.